We are in week 3 for Algebra 1B. All right, what are we going to be doing? We're going to be adding and subtracting monomials and polynomials. So what does that mean? Well, right now, here's the vocabulary. Not much, because this is a pretty straightforward lesson. So really what it means is just polynomial just means multiple terms. Now, what do I mean by that? Well, I mean this. Let's see. So we can just get this going here. Something like this. Something like this. All right, so polynomial versus monomial. So polynomial, right, just means that there's multiple terms within your, it's not an equation, it's more like an expression. It's just multiple terms together. By terms, I mean multiple terms with different powers and variables. So for example, 3x squared plus 3x plus x plus 1. Each one of these things, right, all of them have a different power. By the power, I mean this number, right? This one, whether or not you are, whether you know it or not, they have different powers, right? Now, this is a polynomial, and usually what we would do before this is we would establish what it means to combine like terms, right? There's this, I've briefly used this before, but I don't know how many of you actually have, used this. What that means is if you have the same power and the same variables, you can combine those two things together. So for example, here, right, all of these have a different power except for these two, right? Within this polynomial, there is two terms, right? And each one of these is a term. Two terms have the same variable and they have the same power, which means I can combine them. So if I were to simplify this, we end up with 3x squared. The 3 and the 1 is the only thing that add together. So 3 plus 1 is 4. So that's plus 4, and I keep the power, x to the 1 to the first power. And then anything that doesn't get combined just comes down. Now here, I can't do anything else here, right? I can't simplify this polynomial any more than I already have, right? That's just it. That is my polynomial. That is my expression with multiple terms, right? But that's really long to say, so we just say polynomial. So if that's a polynomial, what's a monomial? I might be spelling this wrong, but it's okay. So here, a monomial is just, it's something, it's exactly what it sounds like. It's just one term, right? So let's say I had this, right? A polynomial with only one term. This is what we call a monomial, right? And if we were to add multiple monomials, right, it would be this. It would be this, right? And then, we were combining like terms here, right? The 3 and the 3 get added together. The coefficients will add together. So 3 plus 3 would be 6. The x's, because I'm adding them, they're just going to stay the same, right? When I'm adding monomials, I'm basically just combining like terms is really what I'm doing, right? Because, and then what happens is if you can't add the monomials together, right? Because let's say they're not compatible. Let's say instead of these guys, right, I had something like 3x squared plus, give me a second to get rid of that. Okay, I had 3x squared plus, I don't know, 5y, I don't know, cubed or something, right? At this point, I have two monomials and I'm trying to add them, but because they have different powers and also because they have different variables, I'm unable to add them together. Therefore, they're kind of just going to hang out together and they become a polynomial because they're still together, right? So that's just a basic rundown of what these things are, right? This is what we're going to be working with. We're going to be adding them and subtracting them, all right? And there's two different methods. I personally prefer one method over the other, but you guys will have to decide. So right here, adding polynomials using vertical method. Now, the vertical method is when adding polynomials, you place one polynomial on top of the other one. This should bring you back to like regular addition, like when you guys are adding things by hand and you're using this, the standard algorithm, the standard method. It's the same concept. In other words, I have a polynomial on top, I have a polynomial on the bottom, and I'm going to add all the numbers that I'm able to add, right? Okay, so what does this look like? Well, why don't we look here, right? This is our polynomials. I'm told I need to add the following polynomials: 5x raised to the second power, right? Now, remember, I'm right here. Undo, okay. Oh, dear, I need to fix that. Okay, I'm just not going to draw there. I don't know what's wrong with my computer. All right, so we have 5x squared plus 2x minus 1, and we have our second polynomial, 4x raised to the second power minus x plus 2. So what are we going to do? We're told that we need to add them. The first thing we should always do is put them in parentheses. And the reason for this is because they're two separate polynomials. We want to make sure everything is separated first, and then we want to check if all the signs are correct before we do anything else. This will make sense when we subtract them, but it's always a good idea to do that. So when given two polynomials, put one on top of each other and make sure the powers match. Once I put the parentheses around them, which is what I did here, right? Which is what I did there. Um, I'm going to keep the one on the left. I'm going to keep this one where it is, and I'm going to move this one underneath it. Okay, that's all I did. I just moved them positions, and I ended up with this. I ended up with 5x squared plus 2x minus 1 on top, and then I'm going to add 4x squared minus 1x plus 2 on the bottom. All right. Once they're on the top and the bottom, I'm going to go ahead and add them vertically. So I actually create a system in which each power can only add to the other power. So I don't know if you guys remember this, but if I have something like 3x squared, the only time I can add it is with another one that has the same variable and the same power, right? I can add this together. But what I can't do is I can't just add, this. I can't do this because even though they have the same variable, they do not have the same power, right? So therefore, they're not compatible. Therefore, they don't belong in the same lane. And what do I mean by the same lane? The same column. You see how I divided it over here, right? See how I made these little lines? 5x squared can only add up to the 4x squared. And if there was like another x squared for some reason in there, yeah, I could also put it on the bottom there. It would just kind of continue. In other words, I'm gathering up all the uh, the like terms from both polynomials, and I'm putting them underneath each other, so that when I add them, I know that I need to add the numbers. So the 5 and the 4 become a 9, right? The x squared doesn't change, which means that 5x squared plus 4x squared is going to give me 9x squared, right? You want to think of the x squares, right, as a label in this case. I know that last week we were doing the rules of the power rules and you saw how all of them changed. This is a different aspect to that. We're not concerned with the powers. We're actually more concerned with the coefficients. How do we deal with coefficients with different powers? In this case, this kind of acts like a label. The best way I can describe this is, imagine if x squared for whatever reason represented apples, right? And for whatever reason we had x represent, I don't know, cars or whatever, right? If we were to read this polynomial with this in mind, right, we could only add the apples with other apples, right? We could only add the x squares with other x squares. Because otherwise, if you try to add an apple and a car, you don't get anything. You just get an apple and a car. They don't combine. They're not the same thing. I can't say, if someone has a car and I give them an apple, and then I said, well, I'm giving you this apple, you're adding it to your car, now you have two cars. That doesn't make any sense, right? In other words, right, this cannot add with this because they are not compatible, okay? They're not the same thing. They don't represent the same thing. Okay, with that in mind, right, hopefully that made some sense. All we're going to do is we're just going to add the coefficients. That's it. In the second one, where you see where you have, we're in the second one right here, where it says 2x, positive 2x, we have a minus 1x, right? Now, if you notice this 1x right here, right? Where'd that 1 come from if the original one is just a negative x? Well, whenever we have a variable, right, like this, there's always a secret 1 there as a coefficient. There's always a secret 1 as a power. And that's something you got to remember. Just because we don't put it there doesn't mean it's not there. You always need to remember, if it's just a variable by itself, it's not by itself. It has a 1 in front of it. Whether it's a positive or a negative, it doesn't matter. It has a 1 in front of it. Therefore, it has a value because there's exactly 1x that you see there. And it has 1 power, right? The power of 1, because x is just itself at that point. All right. So that's where that 1 came from, right? So 2x, positive 2x minus 1x is going to give me a positive 1x. Now you have to be really careful about the negatives, right? And the positives. Keep track of all of them. Don't make sure you put them in there. Make sure you're showing them, right? So that's where I got this 1x. Notice I didn't put the 1 in front of it, right? That's by choice. Then the last thing, we have negative 1 plus 2, right? So what are we going to have? Well, we have plus 2 minus 1. It's just positive 1. So what ends up happening, right, is I end up getting this as my answer. When all is said and done, I have 9x to the second power, or 9x squared, plus x plus 1. And that is the result of me adding those two polynomials. Okay, cool. Hopefully that made sense. Let's go down to the second example, because the second example is going to tell you what do you do if they don't line up so nicely, right? What happens? Well, here we're looking at this polynomial right here, right? We have 3x squared plus 2y plus 1 and y squared minus 1. There's already a problem. The problem is the polynomials are not the same size, which means if I try putting the second one underneath the first one, there's going to be, where do I put them? Right? I'm missing one of the terms. Well, whenever you're missing one of the terms, what you want to do, you want to replace it with a 0 as a placeholder. You're not pulling out a random variable out of nowhere. All it means is that there's a placeholder. It's a blank space, right? So just to make sure that we're on the same page, I'm going to redraw it here. I have it typed out there, but I just want you to see what I'm talking about, because if you notice the powers, right? We have a 2 and a 1, and then we have a regular 1 right there. And then we have the other one, we have a y squared. Okay, so the y squared is going to go underneath here. And there's a hidden 1. And we know that this is a plus. Okay, cool. Good so far. But then the only other term in the second polynomial is a negative 1. Well, the negative 1 belongs with the regular 1, right? Like this. So then what do I put in this right here? What goes here? Well, you have two options, and there different people do it different way. I will accept either way. You decide whatever makes the most sense to you. You can leave it blank like I'm doing right now, right? Or, right, for some people it helps to actually have something there because it vexes them to like not have anything there. It looks weird, right? I've heard a lot of people say that. So if you feel like you need to have something there, what you can do is you can just add 0 y to the first power. This is just to remind you that, there's no second first power, right? So then what ends up happening is this just kind of straight goes down, right? Nothing changes with it. This one cancels out. And then this one, we get 3y squared. We get 4y squared plus 2y, like that. And then that's where we get that from, okay? So I personally don't care which one you do. If you notice over here, if you look at like what I did here, this is equal to that, right? Will I accept either answer? I would prefer that if you have any zeros by the end of it, you didn't include the zero. So like if you notice here, when I say simplify if necessary, the only thing I really did from the one on top of that to the one below it is I just didn't include zero. That's it. But otherwise, my answer remains the same. I'm the kind of person who, if I don't have to put like extra zeros and extra ones and extra whatever, I won't. But I understand that that's confusing for a lot of students. So if you need to put them, put them. It doesn't matter to me. I just think that once you get used to it, it is a time saver. Okay, so moving on, subtracting polynomials using the vertical method. Very similar, except the major change with subtraction is order matters, right? Because although I didn't say it that much in the last one, right? When you were adding them, yes, I told you to put the one to the right underneath the one in the left, but in theory, you could put in them in any order because you're just adding. The answer isn't going to change if you put them out of order. But in subtraction, that matters. Order matters because if you put one of them first and the other one second, the negative goes to the wrong place. Right. This is going to matter more for word problems, but for now, just know that if you're given something like this, right here, 4x squared minus x minus parentheses negative x squared minus 1, the first thing you should always do is distribute the negative. Now, that's what I did here, right? That's what I did there. You have nothing happened with the polynomial to the right. Nothing happened to that one. But I am distributing the negative to the right to the polynomial to the right. Sorry, I think I said right too many times. The polynomial to the left, nothing happens to the polynomial to the left. The polynomial to the right gets a negative distributed, which means we have a negative x squared. Two negatives multiply to give you a positive. That's why it's a positive x squared after I've done distributing it. The other one, right? But the negative doesn't just go to the x. If you see the arrows, right? The negative is also being distributed to the negative one. So you have negative, negative one. Negative times a negative, right? Will give me a positive. So I end up with a positive one. So in this manner, I get rid of the subtraction by distributing the subtraction to the polynomial to the right. The polynomial is now positive for the most part. Now I can add them. Right? Now I can add them and I use the same method as I used in the last one. Right? So far I did that. Place the second term under the first one and now add them. So you see that this gets placed underneath, right? But this time they're adding, and if you notice, each individual term has its own positive or negative, and that's really important, right? So in this case, right, the x squared is positive, so it gets put underneath the 4x squared. So it even though there's no number in front of the x squared, it always has a 1. So 4x squared plus 1x squared is going to give you 5x squared, right? Again, if you need to draw the lines like this, right, just be very careful, right? Because when you draw the line, be very careful not to block any of the signs, right? Yeah, I know that's not very good, but I just wanted to point it out that each one of those is a separate calculation, if you will, right? And we're going up, we're going from up to down. So that's how we end up with a 5x squared. And then we have a minus 1x from the original, right? And then we have a plus 0x. Why? Because in the second polynomial, we didn't have any regular x's. We didn't have any x's to the first power. So I just put a 0 there. I put a placeholder. It doesn't. There's nothing really there. So that negative 1x just kind of came down and became negative x. I didn't do anything else to it. Then we have 0 plus 1, right? And again, anything you add 0 to anything, you're going to get the same thing that you started with. So 1, right? And that leaves me with my final. Okay. That leaves me with, let's not do that. Let's leave me with my final, which is 5x squared minus x plus 1. When I said simplify as needed, here I didn't really need to simplify them. I just kind of left it at that. This was my final answer. Minus x plus 1, right? And in the problems where it's just asking you to add or subtract them, you'd stop there. You wouldn't need to do anything. In the word problems, when they ask you, hey, by the way, if x is like 3, what would the answer be? You would just replace all the x's with a 3 if that were to be the case, right? Okay, so we'll have another example for that in a future video. Just make sure you're watching. So in here, let's move on to the second problem right here, because this one looks a lot more complicated. And truth be told, it is more complicated because unlike the previous problem, we are subtracting, but in this case, right, there's a lot more blank spaces that have to happen, right? Okay, so here, step 1, in subtracting, distribute negative to the second polynomial. So like with the last one, right, this went to this went to this, and this went to this. So if you notice, the negative went to everything, right? We have negative, negative, x raised to the third. We have a negative and a positive y, and then we also have a negative and a positive x. So what ends up happening is negative times a negative gives me addition. So I have x cubed, a positive x cubed. And remember that positive, that's going to stay with this x cubed wherever I decide to put it. It goes along with it. Just like the negative and the positive will give me a negative y, and that negative is going to follow that y. They're a package deal now. The negative and the positive x is also going to give me a negative x. So this is my new, this is the polynomial I'm going to put underneath the first one. Okay. So now that we've done that, now it's actually time to subtract them, right? So in the original, it looks like there really isn't anything that I need, right? I have here, I'm looking right here. Everything I think is pretty straightforward at this point. So we have the negative 1 x cubed plus a 1x cubed. Those are going to cancel out, right? What happens here is I have a positive of something that I have the negative of. They're the exact same number. They cancel out. It's a 0. I'm not even going to mention it as the answer. I'm just going to cross it out right there. All right, the next one. We have 1y squared. And then the second one, like if you notice here, right, there was no y squares anywhere, right? So that's why I have to put a 0y squared. Or I can just leave that part blank. But if I'm going to leave it blank, the reason I'm so, give me a second. Right, so, all right, sorry about that. Let's see. Right, so at this point, it just comes straight down. We have 1y squared, and then plus. Now, if you notice, we have a plus 1y and a minus 1y, so that cancels out. And okay, so that cancels out. And then we're just left with the minus 1x and the minus 1x. So when you combine those two, when you subtract a negative number from another negative number, you're basically adding them, but you're keeping a negative, right? So it's a negative 1, and a negative 1 gives you a negative 2, right? So we have this. Another way you could have written it is just y squared minus 2x. Yeah, that's an x, sorry. Okay, there you go. Oh, that's terrible. Okay. Yeah, so you end up with that. And that's basically how you subtract using the vertical method. Okay. All right, so what about adding using the horizontal method? So the horizontal method, I think is a little easier, but I'm the kind of person who just, I'm not a very visual person. I'm a very linear person. So I prefer this method personally. However, you do need to know how to do both. And throughout the different days, you will be required to use a different method each time because it's a different set of skills that you're using, right? So for step 1 here, we're going to add this, right? We have 5x squared plus 2x plus 1 as a polynomial plus negative 4x squared minus x minus 2. Step 1, identify all the like terms in both polynomials and group them together. What I mean by that is I'm going to underline the like terms, and then I'm going to circle the other like terms. And then I'm going to put a little square around the last ones. Now, it worked out in this point where for every on the left side, for every mark on the left side, there's an equal mark on the other polynomial, but that's not always going to be the case. So in this case, I got lucky. They all kind of match. What do I do now? Well, all the numbers that I underlined have the same power, right? We have 5x squared, and I underlined negative 4x squared, right? They both have the same variable. They both have the same power, which means that they're both compatible. They're like terms. And if they're like terms, I'm going to group them together. This is called grouping them. I'm going to put them in the same parentheses, like this. This is one group now. It's in its own separate parentheses because I need to combine these two. Then I'm going to add that with another parentheses. The other ones, let's see the 2, right? The 2x has the power of 1, right? And the other one was a negative x, which also has the power of 1. So they're like terms. So I'm going to group them together, right? And I'm going to add them to the next one. The next one would be, let's see, 1 and 2, right? So we have 1 from the first one. They're regular numbers, so they belong together. All these things are going to be added together, right? Just I'm going to solve each one of these independently first, and then they're going to form the final polynomial at the end, right? So you make sure you keep all the signs right. So in this case, we end up with x squared, right? This ends up with, I know it's kind of backwards, so I'll fix that right now. X squared, right? Because 5 minus 4 is just 1, and I don't need to write the 1. So it's just x squared. 2x minus 1x is just going to be x. To the first, if you want to put it, you don't really have to. 1 minus 2 is just going to be minus 1 minus 2 is going to be, sorry, let's see, that is wrong. 1. I mean, yeah, sorry, I'm looking at it and I wrote the wrong answer over there. Where it says minus 2, I need to fix that. Let's see. Okay, yeah. Okay, and we'll just end up with that. Like, that's pretty much what I did. Now, if you're asking, well, this isn't much different from what we did, last time. It's really not. You just have to learn to identify which one you prefer. Like I'm showing you all the things I did on the side, but once you get to a point where you're going to get to a point where you can do all this in your head. And I think that's the key, because if you can get to that, right, once you get to that point, you're good. I still need you to show your work, and I need you to show how you're doing all these things. But ultimately, it's the same thing. Now, I'll give you one more example of adding polynomials using the horizontal method. All right, let's say that they don't match, right? Let's say you have like 3x squared minus 3x minus 3. And then this is adding it to 5x to the 5th power plus 5x to the 4th power, right? So what do you do when they don't match like this? You're going to try to group them together. Like, what should take priority? If you're ever in a situation um, where none of the powers match or none of the variables match, you're just going to put them in greater descending order. That means that you're just going to put the largest polynomial the largest power first, and then it goes in descending order after that. So in this case, identify the largest power, 5x to the fifth, 5x to the fifth power, parentheses. But since there's no other 5, when I'm grouping them, there's nothing to group it with, right? The next highest power, 5x to the fourth, right? But then there's no other power to group it with. And I hope you guys see that there's a trend here, right? 3x squared, there's nothing else there's nothing else that's compatible with it. So I'm putting this all in parentheses because that's how I was taught. And all these are in parentheses now, but there's nothing for them to combine in. So I can just get rid of all the parentheses, right? If there's nothing to do, just put them in descending power order. And you always want to make sure at the end of the day that they're in descending power order like this. Right? So that's what it would look like if none of them match. Like, what am I supposed to do? Your job is to make sure you put them in descending order, right? In descending order of power. And now they're essentially in standard form, right? Okay, so that's adding polynomials using the horizontal method. The horizontal method is just you're grouping them, and I want to see the groups. In other words, I want to see like that step or this step. Otherwise, you won't get credit. Okay, so moving on. All right, so subtracting polynomials using the horizontal method. Now, in subtraction, the order matters, and I'm going to keep saying that because it does. You're going to distribute that negative to every single term. If there's 3 terms in there, you're going to distribute the negative 3 times. If there's only 1 term in there, you're only going to distribute it once. If there were 1,000,000 terms in the second polynomial, you'd have to distribute the negative 1,000,000 times. And by distribute, I mean you multiply negative times whatever each term is. So in this case, right, we have negative times a negative x cubed. The negative and negative multiply to give me a positive. Right? All right. So I pretty much grouped up all the terms, right? All right, so we did that. We distribute them. Now we need to group them, right? So we're going to group all the like terms. So the first thing that I did was I'm going to underline the highest term first. So I'm going to do the x cubed, right? Those 2 that I underlined are the only x cubes in either polynomial. What about x squares? Do I have any x squares? I don't have any x squares, but I do have a y squared, which is the next highest power. Now notice the variables are different here, right? It's something to keep in mind. That's okay. I do have a y here, so I'm going to circle it. Okay. Oh, wait. Whoops. I'm going to circle the y, right? Y squared, but there is no other y squared either, right? So at this point, I'm left with the y's. I'm going to put a little square around the y's. And then the x's, right? Well, the x's are just there. I'm not going to do anything else for it. But you guys see what I'm saying? I'm trying to underline, or I'm trying to set apart all of them, and then now I know to group them together. So the first one, right, should just be negative x cubed. And then there's another one, right, which is a positive x cubed. It's positive because I distributed the negatives to it, and it just happened to make it positive, right? Now we're doing this horizontally, right? So we're not putting it underneath it, but we are going to combine all the groups. So y squared, we established that there was no other y squared, so that's in a group by itself, right? The next one, we have a positive y and another positive y. So we have y plus y. And the next one, the last one, is going to be a negative x and a positive x. Okay, cool. So now we need to add all the like terms, cancel out anything we need to cancel, and simplify if necessary. So in this case, the positive and the negatives cancel out. So because those are the exact same things, whoops, I shouldn't have done the last one there. This one's the one that needs to, is the x. Okay, those need to cancel out. And we have y squared plus y plus y, which effectively translates to just y squared plus 2y. I don't know why there's an x there. Let's change that. Unless, did I? Oh, okay. Yeah, I know what I did. Oh, man. I don't like mistakes. Okay, so right here, what did I do? We have two negative x's is what it is. Okay, so yeah, that's what it is. All right, all right. Sorry, this is supposed to be a negative x and a negative x, and this one's supposed to be a, the first one is positive, but the second one became negative, which means that this one should actually be an x. As you can see, if you're not careful at what you're looking at, like this stuff can be very simple, but if you're not careful and you're not keeping track of everything, the negatives and positives are going to be what hurts a lot of people. Right? A lot of your points that are going to be lost are going to be because you didn't check the negative, you didn't check the positive, and you got the whole thing wrong because you made a simple negative positive change somewhere. Right? So if your answer doesn't look right for whatever reason, just check to see the negatives and the positives. All right. Okay. All right, this time we're working on word problems, modeling with polynomials. All right, so in this case, I'm going to go over two word problems. One which, and we're going to go over like the key terms of what you should be looking out for and what you shouldn't. So for example, problem, a farmer, that's supposed to say farmer, sorry. A farmer must add the areas of two plots of land to determine the amount of seeds to plant. The area of plot A can be represented by 3x squared plus 7x minus 5. And the area of plot B can be represented by 5x squared minus 4x plus 11. Write a polynomial that expresses the total area of both plots of land. Interpretation. Okay, so what I thought when I immediately saw this was just, all right, there's two plots of land, and I have a very vague polynomial that represents the size for each of those lands, and I need to add those two polynomials. So this is an adding polynomial problem. All right, cool. I can either pick the horizontal or vertical method to solve this problem, but at the end of the day, I'm still just going to add them. I should get the same answer. Now, for the vertical method, I literally just grabbed the first polynomial that you told me. And keep in mind, this is adding. We've identified that we're adding. So it doesn't matter which one goes on top and which one goes on the bottom. You're going to get the same result either way. But in this case, the first one that they told me, the 3x plot of A, right? Like plot of A plus plot of B gives me my final, right? And in this case, I was lucky, right, when I did this because for me, these problems, these polynomials, they all added up. They each have their own counterpart, which means that I have a 3x squared, right? And if I have a 3x squared, the other polynomial also has a square. It has a 5x squared, right? So I'm able to put that underneath the other one. Cool. Then I have a 7x to the first power, and then I have a negative 4x to the first power. So I'm able to put that underneath. Then I have a negative 5. Then I have a positive 11. So I'm able to put the 11 underneath. And if I were to add them all up, I end up with 8x squared plus 3x plus 6. that is what we call the polynomial. It's a polynomial that represents the total combined land. Okay, the total combined land. Now, if I knew what X was, like let's say that the farmer went out and did some measuring and was like, well, X in this case happens to represent like 5 feet or something. And I want to know how much this is in real world terms. All I would have to do to figure that out to solve this polynomial is just replace X with 5 and then use all the rules I learned to solve the polynomial, right? Before we go into what that looks like, let's look at the horizontal method right here, right? So here, the same thing. I just write them next to each other, and then I group them up, meaning this is the same as this is like terms with this, and this one is like terms with this one. So I just grouped them up into their own parentheses. I combined all the like terms, and I ended up with the same thing. So you might be wondering at this point, well, okay, what were you talking about the whole replacing them? Well, okay, let's pretend that X is equal to 5. And the farmer wants to know what his total amount of plot is, right? If that's the case. Well, all I would really have to do, right, is replace all X's with 5s, right? And then I would find out how much land the farmer owns. Notice I'm doing this with the new one. I'm doing this with the finished equation, right? So in this case, what would I do? How would I solve this? Well, I always want to think about what takes order of priority, right? In this case, parentheses do take priority, but there's nothing in the parentheses except, you know, um, except the 5. So there's nothing to really solve there. Exponents takes priority after that. So this gets solved. So this becomes 8 times 5 times 5, which is 25. And then we have 3 times 5 plus 6. Now we do all the multiplication, right? Because multiplication is what gets solved after. So 25 times 8, right? If you get 8 quarters, that's $2. So this will be about 200. Plus 3 times 5 is just 15. Plus 6. So then this becomes 221. Now what this could mean, I don't know. Maybe if X represents 5 feet, then he owns 221 feet of land. If 5 is miles, then he owns 221 miles of land, right? It all just kind of depends. We don't know. But if they gave us a value for X, we need to plug in that value, right? All right. Now, let's look at another slightly harder example, right? This problem is very, very much the same. Problem. The cost in dollars of producing X toothbrushes is given by the polynomial 400,000 plus 3X. And the revenue generated from the sales is given by the polynomial 20x minus 0.00004x squared. Write a polynomial expression for profit for selling 200,000 toothbrushes. All right, interpretation. What is this? What is the problem asking me? Well, the problem is basically a company going around and they're like, all right, guys, we're in the business of selling toothbrushes, right? And this year we sold 200,000 toothbrushes. Now, we might have sold 200,000 toothbrushes, but there's some costs that we incurred. It cost us a certain amount of money to make and distribute those 200,000 toothbrushes. There is a fixed cost of $400,000 that we use for, I don't know, whatever, right? But we wasted that upfront. And then we had some other costs for probably like delivery or what else. And that's modeled by 20x minus, that's the minus 0.0004x squared, right? That represents additional costs that kind of kept piling up, right? So what they want to know here is if I sold 200,000, right? How much money did I make at the end of the day, right? Well, in order to solve this, you have two polynomials and cost is associated with subtraction. Whenever you hear cost, this is a key word here. It's subtract, right? And you know that this is a subtract polynomial problem. And you know that there's two ways you can do it. You can do it the vertical method or the horizontal method. It doesn't matter because you're ultimately going to end up with the same polynomial. You just pick which method. Remember, for word problems, you get to decide which method, whether horizontal or vertical, works best for you. For the other kind of problems, if the instructions say specifically, I need you to do this in one way or another, you need to do it in that way. Okay. So here, uh, we just ended up putting in like, I'm looking at the vertical method right now. I just put one underneath the other, right? And it's subtraction, so I made sure to distribute, right? Remember, we're distributing the negative. So and then I am putting it underneath. Now, if you notice, I put them by what they're compatible with, the like terms. Like there was no x squared in the second polynomial, so I didn't put anything underneath it, which means that this just went straight down, right? And it didn't have to do anything with it. The 20x and the minus 3x resulted in a plus 17x. And the minus 400,000, that was like a fixed cost. That wasn't like anything new, right? That was probably what it cost to produce the toothbrushes. The 4x squared, the negative 4x squared is probably cost incurred in storage, transportation, other things, right? Like all the other things that are required to get it to the store. And the 20x minus 3 is your actual profit margin, right? So we kind of just combine those two things into one, right? This single this single polynomial represents my profit margin minus my cost. And if I put any number for X, it should tell me, right? If I wanted to know how much profit I would make if I only sold one toothbrush, right? I could replace X with one and I can get my answer. If I sold 1,000,000 of them, I can just replace all the X's with 1,000,000 and I would see how much money I made. That you've created an equation or a polynomial that'll give you that information. That's what the word problem wanted. The second part of what the word problem wanted is, hey, we checked, we sold 200,000. How much is our profit margin, right? How much money did we make? Well, that's this part. So I just set up the polynomial, and if you notice, I plugged in 200,000. I plugged it in here. I plugged it in here because there's two x's. Now, this might be a little tricky, but in the calculator, what I did, right? I just had the negative 0.00004 x squared, right? The 200,000 squared happens first. This ends up being 4 with 10 zeros, right? And then this whole thing is being multiplied by the negative 0.0004. And because I'm multiplying it by a number that's a decimal and it's less than one, this giant number will be reduced to just what was it? It was 1.6 uh, yeah, 1.6 million dollars. That's where I got that number from. Now, the 17 times 200,000 gave me 3.4 million, right? And this is positive, which means this is how I know that this is my income, because this is my profit margin. This is how much money I brought in by simply just selling the toothbrushes in the store. I made $3.4 million, but then I had to pay off all the costs that it required to produce, right? To produce all those toothbrushes, I had to pay someone $400,000 to make those 200,000 brushes, and then I had to pay $1.6 million to store the toothbrushes, to drive them to the truck, to have them transported to the stores, to for salaries, for whatever, all my costs, right? All my other costs, and then I subtracted them from my profit margin, my money, and my profit margin is 1.6. Uh, let's see. Oh, I'm sorry. That's supposed to be a 4. Okay. All right. There you go. 1.4 million in profit is ultimately what it comes down to, and that's it, right? If you notice, there's the two parts to this. There's the vertical and the horizontal method. That was just to find out the polynomial. That was just to find out something that would give me the answer. Like, let's say I had, like I said, let's say I didn't sell any toothbrushes. Let's say, for some reason, right, all of my toothbrushes were came out defective or something, and they had to be recalled. And well, what would my profit margin look like? Well, if there's zeros, right, I would still be in debt, right? Because what happens is there's two x's, and yeah, zeros will cancel out, like the first one and the second one, like they would cancel out uh, this and this. Sorry, let's see, draw there. They would cancel out this and this, but ultimately, I would still have the 400,000, right? And if I paid someone $400,000 to make 200,000 toothbrushes, and then all those toothbrushes were defective and they couldn't be sold in the store, the best case scenario is I'm down $400,000. So no matter what number you put in here, right, you get a pretty good idea of how the business is doing, which is ultimately the point of these polynomials, right? All right, so that's it. Thank you.